Okay, so we are starting a new unit, and our first lesson here that we'll be able to solve some proportions. So we're going to have to go through a little bit of vocabulary in the first slide or two, having to remember what exactly is a ratio, and trying to remember what is proportion, and then techniques on solving them. But before we even have techniques on how to solve them, we probably first have to learn how to verify that we really do have a proportion. And then when we get to the second lesson, then we'll see how we can apply the skill to some geometric figures. But for the time being here, it looks like it would be a good time to proceed and find out exactly what this math skill is. Okay, so two methods for checking to see if two ratios form a proportion. Now, if I see a fraction, you've got to remember that that is a ratio. All right, so when we talk about ratios, you're like, oh, it's a fraction. And hey, look, there's another fraction. In other words, another ratio. Well, if those two fractions are equal, or using our more appropriate vocabulary, if those two ratios are equal, they form a proportion. And so we need to check and say, hey, if I give you two ratios, do they really form a proportion? Well, one method of checking is just reduce each fraction. What would I do with 8 over 12? Well, there's a common factor of 4. Cancel out that common factor. And so the ratio of 8 over 12 reduces to the ratio 2 over 3. Let's see if that matches. What on earth can I do with 6 over 9? Well, there's a common factor of 3. I can cancel that common factor of 3. Oh my goodness, 2/3. They have the same ratio. Therefore, they are a proportion, right? The fractions are equal. So the proportion is true. Notice you can pretty much switch and swap the word fraction and the word ratio back and forth. Oh, we've got to take a look at a second method. Now I'm going to use the exact same two fractions. Right, so I'm going to have that 8 over 12 again, and that's 6 over 9 again, and we're going to cross multiply. So to cross multiply, the denominator of one fraction has to multiply the numerator of the other fraction. 6 times 12 is 72. And then the numerator of that fraction will multiply the denominator of the other fraction. 8 times 9 is 72. That's why we call it cross multiplication. Notice that the 72 equals 72. The cross products are equal, so the proportion is true. Right, so those are my methods. I can either reduce both fractions, or I can cross multiply. And as long as I get the same result, in other words, the 2/3 match the 2/3, that method worked. Or the 72 matches the 72, that method worked. Okay, physical abuse of a calculator. Right, you take a hammer to it and you sledge away on it. We do not want to physically abuse a calculator. What would be mental abuse of a calculator? Well, for mental abuse of a calculator, right, if I want you to reduce a fraction, let's do it by hand. If we have to cross multiply, as much as possible, let's do it by hand, right? The calculations I did on the previous slide did not require a calculator, right? So mental abuse of a calculator is pushing buttons on that calculator when you really should just be using pencil and paper or doing it in your head. Now, every so often I have to unteach something that was taught in lower school, right? Sometimes elementary school teachers, they get a little bit frustrated and they say, hey, push buttons on the calculator will reduce the fraction for you. We're going to get in a time machine and we're going to zoom to the future for just a moment. So next year you'll be in second year algebra, algebra 2. And if we came across a question in algebra 2, I might say, hey, reduce this fraction. Do you remember how to reduce a fraction? Well, we have to factor, because we are only allowed to cancel factors. Right? If there's a common factor, that can be canceled. And then I have the fraction reduced. Right? Notice I didn't try to cancel the x squared with the x squared, right? Because those aren't factors. I have to have only multiplication going on to be able to cancel. So that's why it's so crucial that we understand how to reduce fractions by hand and not rely on a calculator. Okay, let's go back to geometry. Okay, let's do some examples of what we're going to be doing here in geometry. Okay, I might insist that you reduce the fractions. So, are those two ratios a proportion? Well, if I reduce the first fraction, I get 4/5. If I reduce the second fraction, I get 7/8. Uh-oh. 4/5 and 7/8 are not the same thing. No, those ratios do not form a proportion. Let's try a different example. Let's try 18/24 and 15/20. Would these ratios create a proportion? Well, reduce the fraction. Reduce the other fraction. Hey, 3/4 is the exact same thing as 3/4. Yes, those ratios do form a proportion. Now, what if we actually want to solve? Right? 6/15 equals x/25. Now, reducing the fractions really doesn't help me too much because I don't know how on earth would I reduce an x/25. So what was that second method? Cross multiplication, right? We're going to cross multiply. So I'm going to have to do the 15 times the x. That'll give me 15x. I'll have to do 6 times 25. Set those equal to each other, right? Because if those ratios form a proportion, the cross products must be equal to each other. So 15 times x must be equal to 6 times 25. 6 times 25, this would probably be an acceptable time to grab a calculator. Not too many of us are going to do 6 times 25 in our head. 150 divided by 15. Hopefully you can eyeball that and say, hey, that's just going to be 10. Ooh, good. Another example. Well, 15 times 4 is one cross product. 10 times the quantity x minus 7 is the other one. Set them equal to each other. 15 times 4 makes 60. And then the distributive property, 10 times x is 10x. 10 times 7 is 70. Let's add 70 to each side. Let's divide by 10. And there you go. X would be 13 for that to be a true statement, for that to be a proportion. Ooh, we got X's all over the place. This is getting even more fun. Cross multiply. Distributive property. Now we're going to want all the X's on one side and all the plain old numbers on the other. I might decide to move the X's first. Move the numbers second. I don't really want 21 times the value of X. I just want the value of X. Divide by 21. Ta-da! X is 5. Now the fun really begins. Let's cross multiply. So the X times 11, the X plus 11 has to multiply the X plus 2. The 2X plus 1 has to multiply the 10. And this is where you really want those village people to show up and start singing their big hit. Math man, today is the day. I say math man, let's multiply this way. It's fun to FOIL. It's right. It's FOIL. It was a big hit back in the day. Right? First, outer, inner, last. FOIL. Right? I need to multiply the first term in each parenthesis, the terms by the outer parentheses, the terms by the inner parentheses, the last term in each parentheses. So first, x times x makes an x squared. Outer, x times 2, 2x. Inner, 11 times x. Last, 11 times 2 is 22. And now I can just do the distributive property on the other side. I can do the 2x times 10. And I can do the 1 times 10. Combine like terms. Now, instead of trying to get all the x's on one side and all the numbers on the other, we've got an x squared. Right? The x squared is not going to combine with the 13x. The x squared will not combine with the 20x. We need to do something different. We need to set the equation equal to 0. So I'll need to subtract 20x from each side of the equation, subtract 10 from each side of the equation. Now you have not 1, not 2, but 3 choices. You could solve by completing the square. You could solve by using the quadratic formula. However, I think in most cases, factoring is going to be the quickest, easiest solution. So let's factor. 2 sets of parentheses. Now for the x squared, I'm thinking I gotta have x times x. I'm looking at the positive on the 12 and thinking, the signs have to match for it to come out to be positive on the 12. The negative on the 7 tells me they're going to be negatives. Now I just got to figure out, well, what two numbers multiply to get me 12, but combine to be 7? Well, negative 3 times negative 4 makes a positive 12. And then when I do FOIL, the negative 3x and the negative 4x will combine to become negative 7x. Now, set each factor equal to 0. And then I can solve. And I've got two answers. X could be 3. That would make that proportion a true statement. X could be 4. That would make that proportion a true statement. No IXL with this assignment. It'll just be a worksheet. Want to make sure that we can work through some proportions here, dust off some old algebra skills and use our algebra skills working. And then with the next lesson, we'll start applying this more toward geometry, in which case there will be an IXL that is applicable. But for this lesson, it is just a worksheet. And we have a happy ending.